Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera untuk kita semua. Pertama-tama terima kasih atas kehadiran bapak-bapak dan ibu-ibu sahabat NETPROMine yang tetap bersupport untuk NETPROMine dan mengucapkan terima kasih. Dan yang kedua, kami ingin menyampaikan bela sungkawa atas gempa bumi yang terjadi di Turki di bulan Februari awal. Untuk sebelum kami mulai, ada baiknya kita turut berpartisipasi dalam mengirim doa untuk para korban yang ada di Turki sana, untuk saudara-saudara kita yang ada di sana. Untuk waktu dan tempat, saya mulai. Selesai? Ya, untuk saat ini saya akan menampilkan dulu show-nya. Apakah sudah terlihat? Ya, hanya refresh sedikit di sini untuk di prolog awal. Ya, NetCat berdiri pada tahun 1989 sebagai leader digital data spesialis dan telah berkembang menjadi perusahaan produk perangkat lunak nasional dalam kontribusi insinyur, akademisi, dan pelanggan di Turki. MYRZ merupakan perusahaan menengah yang sedang berkembang. Kami menangani konsultan dan trading dalam fokusnya energi dan water. Kantor pusat kami berada di Office 8, SCBD, dan operational office kami ada di Cikias, Bogor. Kami berdiri pada bulan Maret 2013. Dan MYRZ merupakan auto reseller untuk NetCat di Indonesia dan Southeast Asia. Ini lokasi kantor NetCat yang ada di Turki dan kantor kami yang ada di Indonesia. Selanjutnya, ini tim-tim Green mungkin tidak bisa join di webinar kali ini, tapi diwakilkan oleh Takbert. Halo Takbert, can you say hello?
Hello everyone.
And then Khatijah, can you say hello?
Hello everyone.
Dan ada NetCat di Indonesia diwakilkan oleh Bapak Yanes Darmawan. Bisa say hello Pak Yanes?
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi semua teman-teman. Salam kenal. Untuk yang belum kenal.
Selanjutnya yang di MYRZ sendiri ada saya dan ada tim technical support kami, Ilham Siddiq serta Muhammad Syarjuddin. Dan ini klien-klien NETPROMine yang ada di Turki. Ini klien kami MYRZ. Dan ini universitas yang telah join menggunakan produk kami. Ada Unsri, UHO, ITB, Trisakti, Unpad, UGM, serta Unsur. Dan ada pemerintahan yang telah bekerjasama dengan kami, yaitu Tekmira. Ya, selanjutnya untuk produk ini akan disampaikan oleh Bapak Yanes. Untuk waktu dan tempat, saya persilakan.
Terima kasih Mas Azizal. Oke. Selamat pagi semua Bapak, kembali saya ucapkan Assalamualaikum warahmatullahi wabarakatuh. Selamat bergabung di webinar kali ini, kesempatan kali ini. Intinya kami hanya ingin menyampaikan versi terbaru dari NETPROMine, di mana nanti Bapak Ibu akan lihat, akan dibawakan oleh rekan kami Tukbek, bahwa NETPROMine sudah banyak mengalami perubahan dari kondisi terakhir setahun yang lalu ya, dengan beberapa fitur tambahan maupun juga front end-nya jauh lebih compact dan lebih enak dilihat gitu ya. Oke, sedikit pengenalan terhadap solusi yang ada di NetCat ya. Jadi NetCat nama perusahaannya, netmine itu adalah nama solusinya untuk pertambangan. Jadi kami itu ada beberapa solusi yang kita namakan netmine, netcap, netikma maupun netlabs ya. Nah, untuk netpromine sendiri itu adalah salah satu solusi dari tambang, which is under netmine, di mana dia untuk pemodelan gitu ya, software pemodelan 3D. Dan selain itu juga kami ada software lainnya yang bernama NetCat GIS, di mana lebih ke arah untuk pemetaan geologi maupun untuk infrastruktur. Jadi lebih ke arah engineering untuk masalah pengairan, hidrologi gitu ya, bendungan, jalanan, hauling dan lain sebagainya. Itu completely software engineering di NetCat GIS, di mana softwarenya itu platform CAD dan GIS itu menjadi satu. Dan tidak banyak kayaknya software yang bisa melakukan itu. Jadi dua software itu yang coba dikenalkan ke Indonesia ya, melalui PT MYRZ sebagai rekan bisnis kami yang official gitu ya. Untuk yang lain-lain, software yang lain kami juga ada software untuk database ya, geological yang mana cloud sistemnya, jadi disimpan di cloud, tapi murni database untuk geologi gitu ya. Itu namanya NETPROMine. Lalu ada juga beberapa software yang kaitannya sama operasional tambang, di mana untuk safety reason ya, untuk juga pengecekan untuk pemonitoran dari grid dan lain sebagainya. Itu adalah software yang lainnya juga yang kita gunakan di tambang juga, tapi juga bisa digunakan di tempat lain. Saya lanjut aja, saya akan fokus untuk di NETPROMine maupun di NetCat GIS karena memang itu yang kita coba kenalkan terlebih dahulu. Lanjut Mas Ali slide-nya. Oke, di NETPROMine sendiri itu basically cuma ada 4 modul ya, geological module, open pit design, open pit optimization, dan underground mining. Di mana geological modeling ini menjadi core-nya. Jadi kalau kita bicara software tambang, NETPROMine ini mirip dengan software tambang seperti Minescape atau DataMine gitu ya, atau Surpath atau Leapfrog, MYRZ, Vulkan dan lain sebagainya. Di mana mereka biasanya yang core ya. Nah di NETPROMine sendiri yang core-nya itu adalah geological modeling. Nah isi dari geological modeling itu sudah semua yang ada dibutuhkan oleh para geologis ya. Dalam artian untuk data export import ya kan, untuk editing borehole analysis, sampai pembuatan untuk solid model, terus general block model, dan sampai ke perhitungan resource estimation, di mana di sana banyak metode-metode yang digunakan untuk create solid model gitu ya, ataupun untuk coba resource estimation, termasuk di sana ada geostatistik ya, maupun informasi pembuatan resource estimation lainnya gitu ya, yang biasanya dikenal dengan simple research ya, biasa digunakan sangat sederhana sekali, maupun metode lainnya nanti akan dijelaskan oleh Cukbuk untuk lebih detail. Lalu open pit design seperti pada umumnya ini my design ya, untuk open pit, jadi ya kita akan membuat suatu pit ya dengan software sampai analisa untuk mengenai environment ya, karena ada blasting juga di sana. Lalu kembali ke optimization, kembali lagi software NETPROMine itu akan coba sampaikan ideal situation atau ideal pit yang harusnya secara ekonomis itu memberikan manfaat gitu ya, yang paling optimum. Si software NETPROMine akan coba memberikannya di modul optimization. Yang terakhir terkait dengan underground, ya tentu saja itu adalah untuk desain di underground. Tidak terlalu banyak di Indonesia, tapi kami sebagai pemasif memiliki fitur ini. Tapi akan dibuat semacam galeri-galeri yang di dalam bawah tanah seperti itu. Oke, lanjut Mas Ari. Oke, ini penjelasannya tadi seperti yang saya sampaikan, kita skip aja. Oke, kemudian untuk NetCat GIS sendiri, seperti yang disampaikan, ini adalah software untuk basically pembuatan geological map gitu ya, plus sama engineering design ya, untuk pembuatan jalanan, hauling atau jalan raya, pembuatan channel-channel, analisa hidrologi ya, termasuk curah hujan dan lain sebagainya, dan termasuk pembuatan bendungan ataupun gorong-gorong dan sebagainya. Itu semuanya adanya di NetCat GIS. Juga di sini ada modul yang namanya SCANet ya, untuk perhitungan NPO. Jadi engineering sekali bisa softwarenya. Jadi kalau nanti ada bapak-bapak ibu sekalian membutuhkan salah satu dari modul NetCat GIS ini itu untuk perhitungan engineering ataupun untuk pembuatan peta dan ke hidrologi ya. Sekarang ini lagi kami ini pada para pelayak permintaan di hidrologi itu semua itu ada di software NetCat GIS. Itu software yang berbeda dari Oke, lanjut. sedikit ulasan ya mengenai product features seperti yang sudah pernah disampaikan ke Bapak Ibu sekalian mungkin di tahun lalu gitu ya. Jadi software NETPROMine itu didesain memang untuk yang cepat kerjanya gitu ya, karena disusun dengan sangat sederhana dan praktis gitu ya, dan juga sangat user friendly, di mana ini berbasis Microsoft semua fiturnya. Jadi yang sudah biasa menggunakan Microsoft, bagi background geologis atau main engineering, tentu saja tidak akan mengalami kesulitan. Adapun yang tidak pun mendapatkan memiliki disiplin di geologis maupun tambang, itu juga bisa mudah mengikutinya dengan melalui tutorial video yang tersedia. Lalu kenapa NETPROMine itu dibanding yang lain? Apa sih bedanya yang sangat signifikan? Tentu saja di area licensing-nya ya. Licensing NETPROMine ini itu adalah single user ya. Seperti biasa single user tentu saja digunakan oleh satu user ya, single seat gitu ya. Namun dia acting-nya itu sebagai network. Kenapa saya bisa katakan sebagai network? Karena fungsi network kan dia tersimpan di satu, dan apabila ada yang menggunakannya bisa melalui jaringan, dengan melalui borrowing mungkin ya, dipinjam, ataupun emang ada IP atau admin ya yang mengizinkannya. Nah, kurang lebih ini bisa seperti itu juga di NETPROMine, cuman dia itu yang berpindah itu bukan gadgetnya gitu ya. Kan misalkan contoh ada suatu user A gitu ya di satu pulau, dan user B-nya ada di pulau yang jauh seperti atau mungkin di belahan dunia mana gitu ya, yang mana selama itu ada fungsi internetnya gitu ya. Nah, si license itu dapat berpindah tempat atau berpindah tangan dengan cara mendeaktifasikannya si license tersebut dan mengkopikannya semacam kayak license code atau soft key ya, kita biasa bilang, itu dikirimkan ke rekan kita yang ada di tempat dimanapun yang ada di dunia. Itu pengirimannya cukup simple, bisa melalui WhatsApp, bisa melalui email, bisa melalui text messages ya, ataupun media komunikasi lainnya. Jadi dengan demikian, license dapat digunakan oleh rekan kerja kita yang lain tanpa harus berpindah gadgetnya. Jadi kita mengenal yang namanya dongle. Dongle kalau misalkan kita pindah atau kita pinjamkan rekan kerja kita kan dongle-nya yang berpindah. Ataupun kalau itu notebook sistemnya gitu ya, di mana si license tersebut tertanam di satu laptop yang berpindah kalau kita mau pinjamkan. Nah, hal-hal tersebut itu kan akan diiringi dengan adanya network ya. Ada network itu tidak perlu gadget berpindah, tapi license bisa dikirimkan, hanya ini membutuhkan suatu admin ya, seorang admin yang mengaturnya, dan itu ditaruh di dalam satu jaringan, di server di suatu klien, jadi klien server, dan pasti itu akan menggunakan port gitu ya. Sedangkan di sini di NETPROMine itu tidak perlu. Jadi cukup berpindah-pindah license code-nya, hanya yang kita dibutuhkan ketika mengaktifasi atau mendeaktifasi license, kita hanya butuh internet sekali aja. Setelah itu berpindah atau setelah itu aktif di suatu laptop atau komputer, itu tidak perlu lagi internet connection. Jadi license bisa berpindah, rekan kita tidak bisa gunakan, tapi aset tetap di tempat dan tidak lagi melibatkan orang IT dan tidak lagi butuh yang namanya port. Gitu ya. Oke, komersialnya itu tersedia saat ini dalam bentuk perpetual. Jadi perpetual seperti namanya ya, abadi, dalam arti maksud abadi adalah si license itu akan aktif forever gitu ya. Dengan catatan tentu saja selama netcat berdiri. Kalau netcatnya sudah tidak berdiri ya tidak bisa lagi dipakai. Tapi intinya adalah selama netcat berdiri itu license itu bisa digunakan forever gitu ya. Jadi tidak perlu lagi istilahnya ya tiba-tiba expired dan sebagainya. Paling di proses perpetual ini ada yang namanya maintenance ya. Istilah maintenance akan keluar di mana apabila kita ingin terus mendapatkan update software, mendapatkan technical support, training dan sebagainya, tentu saja maintenance-nya harus aktif gitu ya. Yang mana akan dibayarkan tiap tahun. Tapi ini sifatnya opsional, tidak perlu misalkan nggak butuh tahun ini support dari kami atau nggak butuh update software-nya. License tetap bisa digunakan tanpa harus maintenance. Opsional. Kemudian ada juga sifatnya subscription ya, atau bahasanya kita itu mungkin berlangganan ya, berbayar berlangganan berbayar gitu ya. Itu ada yang namanya untuk tahunan maupun juga bulanan. Jadi ketika ada bulanan ya tinggal berapa bulan pembelian subscription monthly-nya, dia akan aktif license-nya di periode tersebut. Dan untuk untuk yang annual juga sama, setelah berapa tahun, setahun atau 2 tahun itu akan aktif. Nah, untuk subscription ini menariknya adalah kita tidak perlu lagi yang namanya maintenance, karena pasti ketika kita subscribe yang diberikan oleh kami adalah software NETPROMine versi terbarunya, atau software NetCat versi terbarunya. Karena dalam sesi langganan itu udah otomatis support dan untuk software yang terbaru pasti akan diberikan. Oke, lanjutkan. Oke, ini yang menarik, selain tadi perubahan dari sisi fitur di teknikalnya, di software-nya gitu ya, baik itu nanti lebih compact, lebih jelas, dan juga ada fitur-fitur terbaru di NETPROMine, juga dari sisi komersialnya itu ada perubahan. Jadi sebagai berikut gitu ya, misalkan untuk software NetCat JS gitu ya, kami saat ini tersedia paket ada 5 paket gitu ya, di mana masing-masing paket itu isinya apa aja sih, itu ada yang di sebelahnya, kolom sebelahnya yang namanya modul selected. Ini adalah paket-paket yang kami sediakan, yang kami yakini banyak digunakan oleh para teman-teman di tambang, namun tidak tertutup apabila sifatnya mix. Misalkan surveying, kita mau tambah nih, misalkan kan modulnya ada NetCat JS, ada NetSurf, ada 3D ya, ada NetPro, ada SKNet gitu ya, ada juga untuk water dan kanlit. Misalkan mau di mix gitu, saya mau hidrologi dong, tapi plus water modulnya bisa. Jadi artinya ini cuma sekedar penyajian untuk paket, tapi kebutuhannya nanti tergantung kepada Bapak Ibu sekalian sampai seberapa jauh gitu modul ini yang ingin Bapak Ibu gunakan. Sama halnya dengan software NETPROMine juga. Ini juga ada 5 paket dengan modul isinya masing-masing seperti itu ya. Jadi kenapa ini merah nih? Ada warna merah karena itu core-nya. Jadi untuk software NETPROMine itu core-nya adalah geological modeling. Sedangkan untuk software NetCat JS core-nya itu adalah surveying. Jadi itu memang mandatory harus ada gitu ya. Jadi mau beli modul yang lain apapun, si paket ini yang mandatory ini harus ada. Nah sebelah kanannya lagi itu adalah terkait dengan planning duration-nya. Gitu ya, yang mana ini sifatnya ideal, tapi tentu saja pada pelaksanaannya itu bisa adjustable, dalam artian kita melihat audiens seberapa jauh bisa mengikutinya dan seberapa banyak yang ingin dibahas, itu kita masih tidak terlalu kaku di sana. Oke, lanjut. Oke, paling itu aja yang mau saya sampaikan secara komersial. Sebelum masuk ke software-nya sendiri, ada pertanyaan mungkin saya buka di sini terkait dengan komersial. Silakan. Masih ada waktu 5 menit untuk saya.
Ya, baik. Sahabat NETPROMine yang ingin bertanya nih seputar komersialnya atau sebelum kita masuk produk demo ya, atau mau di akhir sesi juga boleh, nggak apa-apa. Mungkin meternya di akhir sesi aja ya, Pak Yanus ya.
Oke, boleh. Kalau gitu bisa lanjut sekarang ke mana ke software sendiri. Silakan Mas Ari.
Oke, baik, terima kasih waktunya. Dan sekarang kita akan masuk ke sesi produk demo yang akan langsung dibawakan oleh Takbet. Halo Takbet, time is yours.
Hi Arizal, thank you.
Yeah.
All right. So I will share my screen.
Yes.
I think you can see it now. All right. So first of all, I would like to show the interface. The new interface that we've been working on actually is in a ribbon structure. We are calling it ribbon structure because previously we had old tools, but we were not able to see the names of the tools. It was just some buttons that we use, but you should get used to it. So now with the new interface, actually, you can see the buttons that we use for many operations. You can see their names, and we separate those tools into other tabs. The good thing is actually in that structure, you can customize. What I'm saying about customizing, so for example, if you would like to move some of the tools, you can do it from here, like estimation and simulation operations will go under the 3D tools, or it will go under the window. So when you click it, you will see that estimation operations going to move forward to the window. So with that, actually, you can customize how you would like to use the software. Also, there's a quick access tool which you can put commonly used tools for you in here. For example, the navigation tools are quite useful. So by just adding them here, it's a quite good aspect, to be honest. And also, for example, from the 3D tools, let's say sectioning, so getting a cross section. You can add that to quick access tool, and when you use it, it will get its shape as well. So with that, actually, you can easily manage the software. I made some practices before I started, but today, besides from the interface that we prepare, we're going to talk about some of the features of NETPROMine. One of the most common thing that usually people ask to me about the estimation processes. So besides from the interface that we have, we're going to talk about the estimation methods. If you would like to talk about the estimation methods, I think we should start from the beginning, because all of the estimation can't be done without proper information. So that's why I prepared that sample data. And today we are going to talk about that data, and we are going to learn it. We are going to get some statistics about it, and we will see what we can do for estimation processes. So first of all, we have some statistics. If you add the borehole, and if you would like to get a general idea, the first thing you can do is getting some statistics. For example, the length statistics. If you choose the grade, by the way, this is a Chrome project, and the levels, the red parts on the borehole that you see actually contains grade information. But I don't have any statistical information that how long my levels are in that project. Therefore, as an attribute, I'm selecting a grade, and when I click it, I'm getting its statistics. So the minimum level that I have that contains a grade is 25 centimeter. And the maximum, the highest level that contains grade, Chrome grade constantly, is 51.6 meter. And also the other statistical information which can be used in the variogram operations later on, like variance, standard deviation, and skewness. So those information are crucial for me. If I want, I can check export statistics, and when I close it, I will have those statistics in a notepad. So I can copy, I can use that statistics later on. Moving forward, the other statistics that we have, which is quite important also, is the grade statistic. So I do have a grade information, the Chrome content inside those levels, but I don't know how well it's distributed or what's the minimum and maximum content of grade. So when we check, we can see that in different 90 samples, I do have minimum 2.33 grade content as a percentage. And the maximum grade content that I have is 33.55. So that kind of statistics I can get from the software. Besides from that, by selecting a couple of boreholes, you can also calculate the weighted average attributes. So the selected boreholes have average 11.4 almost grade content in average. So that kind of statistics I can get from the beginning. What I would like to do is actually make it more visual. For that, I'm going to use the borehole information, right-click on the borehole, and row sample displaying. This one will display grade attribute to me in a 3D view. So it's going to be much more meaningful. Also, in the legend, I can see that grade distribution. So the software gets the grade information and it's divided into 4 different pieces. If you would like to make it more meaningful to you, you can always edit its range. For example, grade, minimum 0, maximum 35, and the slot value will be 5. With that, I'm going to split that information into 7 equal pieces now. Okay, so in these levels, I do have grade information distributed. If I uncheck the borehole, I will still see that grade information, its levels, and how well it's distributed. So if we check in those levels, I do have the grade information, and this is actually their length. So this length, I do have a grade information, and it's in between 10 to 15 grade range. By using that, actually, we are getting some information about the data. So more or less in those levels, I do have a grade information, and I'm going to make a model that represents that distribution, that levels, and that grade information. What I would like to achieve, getting a geological model, then turn that into a block model, and then assign those values to the block. So at the end, we are going to assign all that grade information into a block model. By the way, I do have a borehole and borehole access, but I made a filter of it. So if I remove the filter, you will see all of the boreholes, and you will also see that those levels are matching with the red parts that I have on the boreholes, which is the lithology that I would like to make a model. So from the legend, if I give some transparency in here, especially, you can see that I do have great information in between 20 to 25, and I do have small grade content in here. I mean, I said small, but in terms of length, actually, it's small. It's like maybe 1 meter or 1 meter and 20 centimeter-ish. So in here, I do have grade information in between 10 to 15, and in here, I do have 20 to 25. So that raw sample display actually represents my model, my future model that I would like to work on. So once we create the implicit model, that represents my lithology or the levels that I have grade information. Let's see it again. Okay, here is a model that I'm going to work on. And as you can see, that implicit actually produced by covering those levels. Those levels in the boreholes actually has a grade content, and I made a model by using those levels. The last thing that I had to do is making an estimation. Once when I'm able to assign that borehole values, the grade values we have in boreholes, I will make an estimation. So with that, I will be able to estimate how much volume of a material that I have in terms of grade. So this is my model, and basically if I check its properties, now all that I can learn is volume information. Let's check. Okay, In here, I can see that I do have a geological model, which is 146.8 almost thousand meter cubic ore. So this is the value of my ore. By the way, this is coma, so my actual volume is 146,000. Okay, besides from that, now we are going to move forward to the block modeling part. But before that, I also would like to show you the composite operation and creating a histogram graph for that model. So if we check, it's, sorry, from here, histogram, by using all of the boreholes. Okay. If I select grade attributes as an attribute that I would like to use, so I will see that there's a graph, and mainly my grade information distributed in between 0 to 21 in general, but I do have a bullseye point, which is in between 30 to 35. So it's a quite small part, and I know exactly where it is. But that's okay. In general, my model in between those grade ranges, and the average grade is 11.22 in here. Besides from that, we are going to make composite. With that, we would like to achieve actually distribution of grade information. So how it's going to happen, we are going to create composite C1, I'm calling it, and the length. If you remember, I had minimum 25 centimeter of length that has a grade content, and the maximum was 51.6 meter. I can also check its length information or attribute information from here as well while I'm making the composite or creating the composite data. Because what I would like to do to distribute that grade information into some levels. To explain it even better, I will use old friend paint. So let's say this is our borehole data, and I do have a lithology inside. So we are moving forward by using the logic. The logic inside is working like that. So while we would like to create the composite information, we are going to have some levels that contains grade information. Therefore, my grade information is actually limited in those levels before I made any operation. So I do have grade content, let's say 12, let's say 8.5 for this level, and let's say 15 for this level. So without making a proper distribution, it's going to be raw information. With the composite, actually, I'm dividing that information into smaller pieces. In here, I am selecting a length. So if I select 1 meter, that means I'm going to distribute that 12 grade information into 1 meter levels. So this level will be produced, this level, one by one. The grade content in it is not going to change inside, because all of them going to be 12 grade if we don't have any other measurements inside this level. So in everywhere, I'm going to have 12 grade information. But what it does, it's actually providing us good information when we would like to assign those values into the blocks. Imagine we have a couple of blocks right here and right here. When we would like to assign some values into the blocks, we are going to read information from directly its level and also its level. If we have separate lithologies like that, we are going to read information from that and information from that. So basically, we are not assigning the average chrome grade of the borehole directly into a block. We are getting that information from certain levels, which we distribute after the composite operation. So I will divide those levels into 1 meter levels, and the acceptance percent, I will use 25%, which means, let's say I do have a lithology like 7.25 meter. So I know how the software is going to behave because it will create some levels for that, actually 7 levels, right? Directly, because we have 7 meter. But what we are going to do for the rest of the 25 centimeter? If I select acceptance percent as a 25%, then that means, okay, if it's a 25 centimeter, create 1 additional level for that. But if it's less than 25 centimeter, don't even bother, don't even create another level for that. Because I'm getting 25%, now I will create another level for that 25 centimeter. Also, if I have borehole and a really small 25 centimeter level, we are also going to create 1 composite level for that 25 centimeter level as well. So in here, whatever is grade, it's going to be shown also. Let's say 14. If we use higher information, we can lose that data. That's why I use the statistics. Minimum level that I have was 25 centimeters. So I also use 25%. I'm not missing any information in terms of grade. As attributes, I'm selecting the grade attributes. I didn't create any additional group inside the boreholes, which I can do. In terms of managing the borehole data, I can separate boreholes into different groups, but I didn't. So ungrouped covers all of the boreholes, which is 94 different boreholes. When I click OK, we do assignment of the composite information. We do have some displaying options. I can display that composite distribution in 2D or 3D. So I'm selecting the grade. As a remark length, I'm using 10 meter. When I click OK, as you can see, I created that levels, and now I'm displaying it. For example, this one. If you remember from the start, we had that raw sample displaying. And I also mentioned that that small part contains grade information in between 10 to 15, and this part was in between 20 to 25. So now I can see that when I make that composite distribution in every level, I can see what's the exact grade information. for every 1 meter. So I have 12.13 in here and 20 in here, which is going to help me later on when I would like to make a distribution, when I would like to estimate the block model with my own borehole data. So like in this case, we are not going to get information from that level. We will get information from that level. So this block more likely in between 15 to 85, 15 to 8.5, not in between 12 to 15. So it's getting lower from that side, maybe also from that side, because there are no separation or no other information. So most likely we're going to use that level. But that actually affects the distribution, and also in the inverse distance method, we are going to create an ellipsoid. So when we create an ellipsoid, we are going to gather information from those levels, and it will also help us. Okay, turning back. So when we make the distribution, I do have great information for all of the levels. And I can also make 3D display, but it's quite similar to this one. It's a raw sample display, and the other one, the composite 3D displaying, is going to be composite 3D display, basically, but it will display the sample data instead of raw sample data. Let me show you. When we did the distribution by using composite, so the raw sample information we have at the beginning, which is 8.44. It's totally fine. And now we do have a sample record in every 1 meter. As you can see, we made a distribution. So the display of the raw sample or sample is not going to change too much. More or less, they're close to each other. But of course, you can also do that. Let's make it. This time, we are going to use the 3D display. When we click OK. Yeah, quite similar. But again, it has different thematic ranges, which I can edit for making it more meaningful for me. Four to 5. Okay, so now it turns to quite similar raw sample distribution. And if you remember from the histogram graph, let me show you again, that bullseye point in somewhere I said I do have a material in between 30 to 35. So this is actually that part. In that level of a borehole, I do have a small site small part that has or that creates the bullseye point. Let's check the object properties of this one. So it has different levels, but in between 27.3 to 29.5, we do have chrome content, chrome levels, and the raw sample record, as you can see, we do have a 33.55% Chrome grade in it. So some people love to take those parts, some people don't. If you want, while we are making or creating an implicit model, you can also remove that small piece if you don't want to include it into your main ore body. So that small piece actually seems like it's containing some high grade information. Okay, now we know the data quite well, actually. The next step is creating a block model by using the implicit model to make a better estimation. Actually, what we create as a solid model also should be used quite well in the block modeling procedures. So at least as a volume base, we need to represent that implicit or geological model quite well. Therefore, we are moving forward to the blocking operations. So in here, we have a couple of options. There's a sub-block criteria, which we can use to create blocks that has half size of the main block. So if I use sub-block criteria 1, that means I'm going to half the sizes of the main block and I will create small blocks. What it does is basically near to the edge, let's draw our geological model. Okay, something like that. We do have the geological model. That means actually I'm going to have main blocks, most likely inside, but near to the edge, I'm going to create smaller blocks. With that, actually, I will be able to represent that volume even better. Let's do that operations. First, I want to use the sub-block criteria, and the block model that I create will contain only blocks that has 4 meters in each direction. So it's going to be a cubic block. Okay, so as you can see, actually, we kind of cover the volume, but some parts are not well represented, maybe. So let's check the information of that block. In a volume base, we created a block model that has 138,000 almost volume block model. So regarding volume, it represents the original solid model like 94%. Let's repeat that operation by using sub-blocks. Now, besides from the 4 meter blocks, I'm going to also place that smaller ones inside the block model. Let's do that operation. Okay, even from the beginning that we can see it covered more. It covered the implicit model more, but let's check the statistics let's count on the math. So yeah, as it says, that block model has 142.2 thousand volume, and in terms of volume, it almost represents like 97% of the implicit. So in terms of representation, I do have a quite okay or quite good block model. Now, the last thing that we should do, actually, we should assign those values into a block model. This is what we would like to do. Okay, so I will get a row sample displaying again. Verify to 5. We will use and check that information later on. Maybe I can change the thematic range also, but yeah. Okay, now we do have a good block that represents the implicit model. We can start making resource estimation operations. I will get a copy of that block. Okay, so now we are going to use a couple of methods that we have for estimation processes, like nearest neighbor, inverse distance, and kriging. Therefore, I can rename the blocks like nearest, like inverse distance method, or kriging. Okay, I put some name to them, so I will make estimation by using those methods into the blocks that has the same name. Okay, now let's talk about the nearest neighbor method. So basically, for the nearest neighbor, you don't need any specifications. Like, as long as you have the composite distribution, you can simply make the estimation. This first one is the nearest neighbor. And when you select the attribute, the grade, you can make a simple distribution. It's getting information from the closest borehole. That's why there are some clusters going on. For example, these blocks and those, probably they got information from high grade levels, and they got that information directly from the boreholes and from the closest borehole. Therefore, we can see more clusterings. I mean, it's also not going to change too much, even if we edit its thematic range. Let's edit. Let's make it 2 to 20. Yeah, like that. So the distribution, that clustering, is not going to change too much. But here we can say that it changed a little bit because it got information from those levels. So it wasn't purple all the time. It was getting information from that borehole, and that borehole has great information in between 10 to 12, more likely. So this one contains 16 to 18. So yeah, this one has a 16 and the other one has 10.07. Okay, this is the simplest method. Basically, what it does from here, if you consider, it's getting the information from the closest level directly and make assignments. So if that levels are 12, most likely the block will be so close to the 12. And if another block that we have is close here, it will be more likely going to be 15. So it's getting information from the closest portal. But now we are moving forward to the little bit advanced method, which is inverse distance method. For that, we need to use an ellipsoid. Before that in NETPROMine, if you remember, we were not showing the ellipsoid, we were expecting the user to write some angles. But now we are also showing that ellipsoid so it can be manipulated easily by the users. So let's bring the ellipsoid parameters from here and click the show ellipsoid. So now we do have ellipsoid parameters in the block. So the first thing that we do, we are selecting the block. There's a one block on the screen. It will automatically choose its center location. It will recognize the block. And then we are going to create a layer for the ellipsoid that we are going to produce. And I select the blue color for it. And imagine those were no information before. So I will decide what is going to be the length of an ellipsoid, the width of an ellipsoid, and the thickness of an ellipsoid. So after deciding that, I can simply apply and bring the ellipsoid here. Yeah, it is here produced in the center, because when we recognize the block model, first the ellipsoid created in the center. Let's give some transparency to our block so that we can see the ellipsoid even better. Actually, those angles were quite okay, but let's make some changes and see how it's going to affect the ellipsoid. So I change the length of the ellipsoid, and when I click apply, it will extend. So 50 meters. And if I change the direction, the azimuth, it will also affect my ellipsoid. So I need to decide what kind of angles that I would like to use. The first, we need to arrange the azimuth information. So if that azimuth is okay, now we're checking that from -x side, or we're looking at the ore body from the side. So now I can also make arrangements for the deep information and the rake information. So the rake information basically helps us to adjust the ellipsoid in up and down sides. So my ore body follows a pattern. It goes slowly to the bottom. So that kind of information that I can use. But if I check the model from this side, the dip should be a little bit like that, because I do have higher thickness on that side. So rake the dip. Yeah. Now, it is looking quite okay, quite adjusted with the angle of the main ore body. So now we are going to make the distribution by using the ellipsoid, but if I want, I can also save that ellipsoid parameters to be used later on and load the existing saves of an ellipsoid parameters. But if we are decided to use that ellipsoid, basically, if we are confident about our ellipsoid, we can synchronize the settings. When we synchronize the settings, all that information will be transferred here. Let's make it so I want you to see that 50 meter we used for the x-axis of an ellipsoid. So when I synchronize the settings, it will change automatically. Also the angle information, right? So I got those settings here. And when I click OK, it will do the estimation. All right. So now we do have an estimation, and let's check. According to grade, I am editing the thematic range. Okay, this is what we have as a distribution. I also would like to edit the thematic of 3D. Quite the same, like 0 to 22 and dividing into 2 meter, 2% ranges, right? Okay. So now let's see them both. So, okay. I have some part of the lithology here. It is in between 18 to 20. Right? We didn't get that bullseye point because we didn't use blocks quite close to that borehole. We kind of removed that piece. And let's check the other parts. So I can see the color of the blocks as well. I can see the transition, right? So in between 0 to 22, 0 to 22, it has to be quite similar when we assign that information into the blocks. So let's remove the 3D, right? Let's bring it back. Or maybe we can remove its area borders. Right? So the actual grade content of a borehole and its level and the distribution itself. Those are quite matching. Even in this side, it's getting purple-ish blocks. In the middle, we do have yellow levels that we have in the middle. We are going into a yellow, but in general, it's the green. In here, it's the orange part that we have. So it's quite fitting. The estimation and the sample displaying are quite fitting, which means we're actually doing something okay in here. Yeah. Therefore, inverse distance method is actually quite useful. One of the most used estimation methods. And the logic behind this, actually, it follows the pattern of a geological model. And we are creating an ellipsoid to gather information from around. But we are not gathering every information. When we create an ellipsoid, like that, for example. Okay, so like that, we are getting information from those levels, basically. Not from here directly, and also levels in here, and also information from other blocks as well. So when we would like to estimate that ellipsoid visits every particular block, this one in this case, our main block will be this one, and the ellipsoid will be produced around that block. When we would like to estimate another block, the ellipsoid will visit other blocks as well. So for example, if it would like to make an estimation for the other one, it's going to look like this. Yeah, so ellipsoid actually visits every block's center and then make the estimation. For example, block in here, it's going to look like this as well. So it's gathering information inside the ellipsoid. If we have a borehole, yeah, we are going to get information from the boreholes. If we have blocks that we already assign some values, it will use that information as well. So with that, it make the assignment. On top of that, ellipsoid direction, ellipsoid angle is compatible with the main ore body, which allows us to make more accurate distributions, or it provides us more freedom while we are making the estimation. So, but at the end, we are assigning values inside the blocks, and this is what we would like to learn. We already knew when we create the implicit model, we already knew the volume, the potential geological model volume, but we didn't know how good it is or what's its quality. And it can be also, let's say, gold content in it, or it's a coal project and we can see the calorie information of the coal. So we didn't know that. We knew that there is some volume as a geological model, but we didn't know what could be the potential estimation. So if we check the IDM with the block model reports now, block report, sorry. So yeah, great. And the density information, let's add 2.23, okay. The density information will just allow me to see the tonnage information. And yes, so according to the grade range, the thematic range, we are getting volume and tonnage information regarding the block. So I knew the model that I produced, the block model that I produced, has that amount of volume, but I didn't know what's the distribution. So 44,000, almost two of them, in between 8 to 12 grade range, I do have 88,000 material, and the rest is actually distributed into other ranges. So in every thematic range, I know how much material that I have. That grade range can be adjusted, and you can get a report if you would like to see that report in different intervals. Let's do it. We have to edit the thematic range. I'm creating a new numeric range for grade. Let's make it 25 and divide it into 5% intervals. Reports, block reports. So I changed the thematic range, and also I got a new report regarding that thematic range. So I do have really small amount of material higher than 20% of a grade. Okay. After the estimation, I do have the grade information inside the blocks, but that doesn't mean we can't assign any other values, because you can assign any information to a block model that we have as attributes. If you have, let's say, attribute information like moisture, ash, other metals, right? Then you can make assignment. For example, let's add, actually it's going to be hard to add another attributes, but let's say you have another attributes like, I don't know, iron content, for example. In your analyzer reports, you might have also iron content, which is totally fine. What is going to happen if you also have the iron content, when you would like to create the composite file, you will also see the iron attributes. So according to that iron attributes, you are going to create a composite. When you create the composite, when you distribute that iron content into the borehole as well, along with the chrome grade, and then you will be able to do estimation. First, you are going to do the estimation for the chrome grade, and then second, that iron will be shown in here when you make the composite. So after that, you're going to select the iron and do the estimation for the iron. So you're going to have grade information and iron information inside any block later on. So yeah, this is actually the process. Now one thing left, which is the kriging. Let's do kriging distribution as well. we do have a block model that is totally clean. If we check its object properties, if we check its object properties, we will see that besides from density, it doesn't have anything. And density also, we didn't assign any density, it's just default. So yeah, that one doesn't have any information. So to make kriging estimation, we need to create a variogram, because kriging also use those variogram settings and the ellipsoid parameters together to make estimation. It's using together the both variogram and the ellipsoid parameters to make an assignment to the blocks. So because of that, we are moving forward to the variogram part. So in the variogram, there is a one classic variogram, which brings a table. And inside the table, we can add vertical and horizontal variograms. And let's say, okay, adding the one direction. So we are calculating the vertical for variogram. We are selecting the attribute that we would like to use. We are deciding tolerance and bandwidth. And regarding the variogram results, actually we are checking the variogram, and then we are deciding which angle we had to use as a variogram. So this is the classic one. Let's make it at least, okay, put some parameter here and show you how it's done. So it's manually bringing one variogram to us in a vertical degree, -90. But now we also develop the variogram map feature. With that, basically, you can automatically calculate the attribute is the grade attribute. When you click apply, it will create semi-variogram values. It will provide you a chart. And from that chart, we can actually select the anisotropy direction that we would like to use for variogram. Okay. The direction that we would like to use is actually the longest axis. So if you check which side will go further, this side, right? So that's why the 60 to 240, that side looks like our anisotropy direction. The longest edge should be in between here, or maybe 70 degree, yeah. So when we understand which angle that we can use by checking that, then we can automatically make that operation. So it will calculate and provide us the variogram in two different angles. Yeah. Besides from 60, it also produced the 150, but I am not going to use that. Okay. I unchecked that information. So I would like to use that one, the 60 degree. So when we click on the model, it asks the nugget effect. If you remember at the beginning, we also get some statistical information, the variance, skewness, and other statistical information. So this is the part that those information will come in handy. You can use that parameters to decide what's going to be your variogram limits, what should be, and according to that, actually, you can make decent variograms. But the main idea from the graphic, actually, selecting a nugget effects that your variogram polyline actually might start. So by clicking on the points, you can directly select one level, but you should also select the variogram and where it starts. So from the point, from here, we got some level, which is 14.7. If I want, I can manually adjust that level. So I can make 13.700. 13.2. Okay, looks like quite fine. Could be the beginning point of the polyline. And for the structure, we need to select the seal value, and usually from the graph we select the point that our polyline turns into another direction. So this is the first breaking point of the polyline. It's turning into another direction. So the seal value, the level, the highest level is 21, which is okay. And the method that I would like to use, Gaussian, exponential, or spherical method could be. And the range is actually making our drawn polyline closer to variogram polyline right here. To make it closer, you need to increase the range like this. But we don't also want that polyline to get inside a variogram polyline. So it should follow from the outside. So we are trying to get closer that polyline as much as possible. But if I use something like 24 range, so it's not quite fitting the variogram, right? So 54 will follow that polyline even better. I can use that range. I can use that angle. I can use that seal value now. So those are my variogram information that I got it. When we click OK, it will actually create a variogram. So 60 degree. I didn't put any information into 150, but now I do create a 60 degree variogram with its information. So it's in our pocket. The next thing we should do, we should create a kriging to make a kriging estimation. So moving forward to the kriging operation. Basically, we create the variogram. So in the second tab, first one is the parameters, and the second tab is the variogram. So basically, we are going to delete this one. Yeah, basically what we have to do is select the structure that we create for a specific angle. So 60 degree structure that I created, I will select. When I select that structure, it will automatically get its seal value, the ranges, the angles that we used. So variogram part is filled, and the other part is quite the same with the inverse distance method, the ellipsoid parameters. And here it says parameter name, but it's a kriging name. So I will say K1. Kriging type, simple kriging or ordinary kriging, I can select. The attribute that we always used was grade, content of a chrome. And if I click show ellipsoid, I need to draw the ellipsoid again. Do I have to need that? No, because from the inverse distance, I can get the values, right? I did that ellipsoid before, so it's going to be the same ellipsoid. 18 and rake 100. Okay. So I do have the ellipsoid parameters here, and I do have the variogram parameters. When we click OK, we are creating the kriging. And from that kriging, we can do estimation for many blocks, basically. So if you click any block, select the estimation and kriging. By the way, you can create a lot of different krigings as well. But while we are assigning, you have to select which kriging you would like to do for the assignment for resource estimation. So the first kriging that we create, we will select, right? And then we will click OK. It will do the estimation. All right. Editing the thematic range. Yeah. Again, that kriging is also good estimation method, well distributed, going to be quite computable with the raw sample data as well as the IDM. It's also a good distribution. We can see the transitions. Okay, now it looks simple, but yeah. So we can see the transitions in here in kriging also. Those are the good methods to be used to assign some values. And if you compare it with the raw sample data or composite 3D display, you will see that it's making quite good assignments. So just compare it with the raw sample data and the composite data. You'll more likely will get closer to its potential. You'll slowly get making more accurate estimations with time. So for that part, there is another tool that we can, it can be useful, which is not this one. You can check its histogram after making a distribution as well, and before that too, so you can compare histograms. And what else? Okay, in here, in that window, we do have variogram and validation methods, and we have a validation for inverse distance and the kriging. If you do that, you will also get a report. It might take quite long because it's checking every borehole level, it's checking the blocks, it's just checking the assignment, etc. So in general, what it does is actually it's controlling the assignment, and eventually it's giving you the potential error that you might make. So in the report, you will see that borehole 1 estimation used for block 1, 2, 3. So different blocks, it's made an estimation we made. So the raw sample or composite, in this case actually, comp data, let's say 15, and the blocks 14.7, let's say 15.2. So it calculates the potential error and then it give you a percentage, let's say 0.03% error for borehole 1 estimations, let's say. And then it does that operation for all of the boreholes, borehole and estimation, borehole to the block. So it calculates all of that, and then it gives you a final report. So borehole 1 is like that, borehole 2 is like that. At the end, eventually, it gives you, let's say, 0.05. I just wanted to make it different. Average, okay. Potential error. So at the end, it tells you how accurate your distribution is. So if you make, let's say, 0.5% or 0.005% in a general estimation, it's quite good, actually. So 95 or 99.5%, depends how you think of that percentage. So the estimation was accurate, 95 or 99.5% accurate estimations you do. So that report allows you to check also. Like I said, you can check the information by using the raw sample data as well. We can check the distribution, how well distributed those informations are. And you can make some filtering to get some meaningful results, because filtering operations in the block modeling, it's crucial, and you can make a filter by using a lot of different criteria. For example, the grade. Show me the grade. Show me the block model that has higher than 15% grade, for example. Okay, those blocks. Maybe 10. Yeah, now at least we have more information. So what criteria we can add also? Show me the block model that has higher level than 435, let's say. Oh, sorry, I select the width, actually, not the Z value. Okay, it has to be block Z value. So block elevation. Okay, those blocks are higher than the specified level, lower than another level. Now, I create a slice, so 15-meter slice by using elevation ranges, right? If you get a report in that stage, you will also get a report of filtered version of the block. So if you do assignments, if you do your resource estimations, you can make a filter and check different information by using filters inside NETPROMine. What else we might wanted to do? Maybe we can create an area and we can calculate block model volume or tonnage separately in some cases. I don't know. I will add inside boundary criteria. When I apply the filter, now the software will ask me to select an area. So now I will select an area 2. It's going to filter that part of the block to me so that I can check its reports once again. So it's changing dynamically all the time. But if I'm going to use, let's say, that separated block in the future, what I can also do, I can get a copy of that block. So it will get a copy of the filtered version of the block. So IDM filtered. Filtered IDM, yeah, okay. And then I will remove the filters on the main IDM method block that I have. Uncheck that one. And whenever I wanted to, I will check the filtered version of IDM. So yeah, this is how we do the estimation operations on NETPROMine. Now I will check the questions if you have, or I can get your questions now.
Yeah, thank you, Takbert, for the demo. It's very nice. Ya, oke, untuk sahabat NETPROMine, apakah ada ingin bertanya? Mungkin Pak Chandra atau Pak Erik Wijaya, Bu Irma, atau Pak Heru, atau Pak Iwan. Kita sekarang sesi tanya jawab. Ada yang ingin ditanyakan kepada kami?
Dari saya belum ada, Mas Arisa, masih cukup jelas kok. Terima kasih banyak.
Siap, Pak. Ada yang ingin bertanya?
Ya, sepertinya sudah cukup familiar mungkin NETPROMine. Penjelasannya sudah cukup ya Pak ya, Bapak Ibu sekalian ya. Oke, nggak apa-apa kalau emang ini belum ada pertanyaan sekarang dan mungkin kemudian nanti ada. Monggo aja Pak untuk bisa menghubungi saya atau Mas Arisa apabila nanti kemudian hari ada pertanyaan. Itu kali ya.
Pak Arizal boleh nanya?
Oh ya, silakan.
Pak Hari.
Ya, hello Tukberg. I'm Hari from Sriwijaya University. I have a question about the open pit design. Typically, we can add slopes at one at a time or all at once. Can we alter a single slope so that it differs on each side of the pit? One side I need a 45 degree of slope. In other side I need a 55 degree of slope. This is my question.
Yes. Actually, there's a transition. Maybe I mentioned that earlier, but do I have a surface? I do have a surface. Let's create an open pit mining really quick. The first one, you need to select the upper surface. So we will get a surface. Let's delete this one and get that surface. So it's going to be blue. Okay, so this is my upper surface. I will draw some area to make the design, minus that side. Let's draw an area. No, area. Sorry. Open pit. Boundary. I can either get the points of the surface or not, it doesn't matter actually, because I can drape later on. I just wanted to adjust that. Yeah, let's say this is our boundary. Oh, I made a mistake at the end. Sorry for that. Area. Yeah. So this is our area, the open pit boundary that we are going to use. Right click from the surface operations. I'm draping that boundary to the surface, right? I am taking that boundary to open pit design. All right, so far so good. Saving the changes. So now we have to decide the default parameters. So downwards inside design, it's going to be, I'm going to fix the bench width. So 65 degree, let's say, 15 meter bench height, 10 meter bench width. Okay, this is the general parameters that we use. And when we do those, and when we create some bench, let's say 6, we produce the same, quite the same bench with the same parameters. That is okay. But now what we would like to do is actually create some transitions so that we are going to use different information. Which different information we would like to use? The bench gradient. For that, we need to define some areas. I need to draw another areas. This time transition, it's going to be, okay. And yeah, so for example, this is my first area, and I will use the second area. I will drape them as well. Okay, now I need to create a transition for that. If we check the bench angle, the bench gradient that we used was 75 in general. Let's make it 65. Okay, to remember. So in general angle, we have 65. But in those areas, I would like to apply different angle. So I will create or add a transition. My default, what it's going to be? It could be a general slope as well. General slope, but in those areas, I am going to use a different value. So all I have to do is define the default value here in the first transition, and then select the areas. Okay, it says now your default value is 65, but which value you would like to use for that area, inside that area, which angle that we would like to use. So I'm saying 45 degree for this angle, and I'm adding the second area, And this one, my default is again 65, but I will use 80 degree. Okay. So I introduce those areas as a transition to the software, but OpenPit design doesn't know that. I'm checking the default definitions. So 65 degree I used. So instead of that 65, I will use R01 definition. The name of the transition, I have to type it here. That part is actually a little bit different. You can do that for the slope angle too. In general slope angle, we have 41.43. So default is going to be 41.43. But in those areas, you might use different general slope angle as well. So you can do for different operations, even for bench height and width may not be logical all the time, but yeah, so bench gradient and slope angle will be useful. If I click OK and produce some bench, again, 6. Okay, let's create 2 more. So when I refresh the surface, let's delete this one. Yeah. Now I will see that I use different angles inside the area. So it's a 65 degree, right? It's a 80 degree, and it's a 45 degree. I can clearly see it's the vertical side of a bench, partially see the side of the bench, and almost not seeing that side of the bench at the 90 degree. So 65, 80, and 45 degree bench gradient we used.
Okay, thank you so much for the explanation. Looks like this will be one of the chapter for NETPROMine Club, University of Sriwijaya. Thank you, Tukberg.
Yeah, no problem.
Ya, terima kasih Pak Hari. Mungkin ada yang lain yang ingin bertanya. Ya. Ada yang ingin bertanya lagi? Baik, apabila tidak ada, sebagai informasi, saya mau namakan pada nanti tanggal 8 Maret akan ada webinar berikutnya mengenai Netcat Hydrology Solution, di mana nanti di situ akan dijelaskan soal hidrologi. Mungkin Bapak dan Ibu yang tertarik dengan tema di tanggal Maret, nanti segera kami kirimkan link pendaftarannya, dan jangan lupa untuk mendaftar, dan setelah mendaftar kami akan kirimkan link Zoom-nya. Oke, kami tunggu Bapak dan Ibu untuk support-nya. Baik, sudah di penghujung acara, bolehkah para audiens untuk mengaktifkan kamera? Mungkin ada sesi foto ya. Kita on cam dulu biar sesi foto.
Nggak bisa on cam, Pak.
Belum bisa di on cam kan itu Pak Rizal.
Oh, oke. Nggak bisa on cam. Oke, siap. Oke, 1, 2, 3. Ya. Oke. Ini layer 1 ya, layer 2-nya. Oke. Baik. Terima kasih para sahabat NETPROMine yang sudah mengikuti webinar kita dari awal sampai akhir. Akhir kata, wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Terima kasih
Pak Rizal.
Banyak ya, Pak Rizal.
Pak Chandra, Pak Erik, terima kasih Pak Haris.
Pak Bu Irma, Pak Heru,
Webinar berikutnya.
Hari dan Pak Erik. Siap.
Ya. Bila ada nanti sesi khusus juga boleh Pak. Monggo, hubungi aja.
Oh siap. Ditunggu Pak upload rekamannya Pak. Menarik tadi Pak materinya Pak.
Siap.
Mungkin minggu depan di next webinar kan hidrologi itu siapa tahu ada kebutuhan atau pengen tahu apa.
Saya mau dong ikut itu yang untuk hidrologinya ya.
Siap.
Siap. Saya juga kayaknya tertarik itu Pak. Hidrogeologi Pak. Oke Pak.
Betul.
Gitu kayak hujan Pak itu sama gitu
Ya,
banjir.
karena memang dibutuhkan di tempat kami ini sekarang ini untuk hal itu ya. Jadi makanya untuk perlu ada tambahan itu sih ilmunya.
Betul Pak. Emang lagi rame nih yang minta juga hidrologi nih. Menghitung aliran sungai ya. Aliran sungai maupun catchment area.
Catchment area maupun juga ya. Memang kembali nanti ke water balance sih memang. Karena kan nanti kita akan menghitung sedimen pondnya berapa sih besarnya dibutuhkan ya.
Iya.
Untuk bisa menampung. Itu
Betul.
sih.
Nanti engineering nanti ke sana ke basin ya, di basin dimension maupun channel dimension.
Betul Pak. Baik Pak Yanes, masih banyak Pak Rizal ya.
Sama-sama Pak Chandra.
Pak
Chandra.
Baik.
Ya. Waalaikumsalam.